Yeah, so yeah, intro to shader graph. So let's start with a bit about me and like why I got into shaders in the first place. So I've always been interested in both like art and programming, and kind of like I started learning Blender at the same time I started learning coding, and so I kind of learned both at the same pace. And eventually, I got interested into in game development, and like it was really cool because I could bring like those two skills together and make something that uses both of those skills in a way. And so shaders um, are something or part of a job called like technical artist. And so when you're a technical artist, you make these shaders that are kind of like they're materials for your object, and also they're like here. Let me just show some examples later, so you can get a grasp on what like shaders do. But basically, there are kind of procedural materials that you can apply to game objects and such. And so that's part of a technical artist's job to do that, as well as like making particle effects and just like visual effects in general. And I find that really interesting. And so here are some examples of what you can do with shaders. So top left is actually from our game Leechbug, which is an AGP, and we use a shader to animate the fish. And so, for example, and also the water shader is something we applied so that you can see through the water and kind of give a sense of depth. You can also make anime shaders, like the one in the top right. Like you can completely change the appearance of materials and how they interact with the lighting. And in the middle, you have this like swirly blob. That is kind of like a combination of particle effects and like refraction, so that like when you look through the blob, it like refracts the things behind it. You can also do cool things like the sheep one, where the shader is applied to the camera, so that when the player kind of like is behind something, you can still see it, which is really useful for third-person view. And bottom right is the shader can also affect the vertices of the models. So for example, you see like the grass moving around when the player goes through it. You can do that with a shader as well. So really, it's all about procedurally changing the appearance of something. Yeah, so let's dive right into shader graph, and I'll talk a little bit about how Unity does shaders. So normally you would write shader code with just like a special language that or coding language, but Unity provided this shader graph where you can just drag nodes around and use nodes instead of using code to create these shaders, which is really cool because it makes it a lot more beginner friendly. So the basic concept of nodes and how you would make something like a shader is that you connect output of something to the input of another node. So what you see here, I have an input node called lifts, which literally just generates a circle. And that connects to 1 minus, which is a math function that says for every pixel in the generated input, I would return a value that is 1 minus that value. So for example, all the black area that you see there has a value of 0, and the white area in the center has a value of 1. And so when you apply 1 minus to it, like 1 minus 0 is 1. So that part turns to white, and then the center circle turns into black. Yeah, so shaders are really a combination of all these nodes connecting together and forming the final shader. Yeah, so some interesting inputs, which I use a lot, are the noise inputs. So the 3 basic types in Unity shader graph is gradient noise, the first one, simple noise, which is just for every pixel, they will generate a random number, and voronoi noise, which is I don't know the calculation behind it, but it looks like cells, which is really cool for some effects. And yeah, and gradient noise is sort of like a smoothed out noise, and so for each pixel, it will like generate a random noise. Yeah, Xian says 1 minus 4 noise bubbles. So you can do like a whole ton of different things, combining these noise with different calculations and such. Yeah, the next thing I'm going to talk about is UV, and that means applying something to change the appearance of the noise or inputs that you saw just now. So you take this Voronoi noise, and for example, you apply a tiling and offset node to it, and you can see that the UV node is affecting how things are positioned in the noise node. So for example, for the first one, we have a tiling and offset node, and I set the tiling to tile 3 times in the x-axis, in the horizontal axis. And when you say I want to tile it 3 times, it squashes the noise so that it looks really squashed. And for the second example, we have a twirl node, and that just kind of like, that distorts the noise so that it twirls around a center point. And there's a bunch of values you can adjust, like the strength of the twirl, you can change the offset and such. So that's pretty useful. Yeah, so I'm also going to talk a little bit about the math nodes. So when you multiply something together, for example, it also goes by each pixel. So for every pixel in that noise texture that you see, it will multiply it by every pixel in the rectangle texture that's below it. And that's why you have this kind of like mask effect. It's because, for example, like remember when I said the black area has a value of 0? Anything that you apply or multiply by 0 is still going to be 0. And so even though there's a whole bunch of values in the noise texture, when you multiply that by 0, it will return black. But then anything multiplied by 1, for example, will retain its original value. So anything that gets added together, even though it appears that like all of this square stuff is the same value, it's actually probably a whole bunch of different values that are above 1. And you can't see this because the preview doesn't display it that way. But you just have to keep in mind that not all of these values are like 1, for example. Yeah, so the value doesn't get clamped between 0 and 1. You have to do the clamping yourself. And I have a slide about clamping in a future slide. Yeah, so there we go, the clamp. Run time. So clamping will make sure that your value is between a minimum value and a maximum value. So for example, if you clamp this rectangle with a value of like 0 to 0.1, then you can see like the brightness decrease from the rectangle node. And that's because even though it has a value of 1, it's over the maximum value. So it gets like shifted towards 0.1. Yeah, so we can also talk a little bit about time, which is really cool for making animated materials. So you have a time node that gives you a time value that increases every frame. So using that value, you can set it to the offset input for this offset UV node. And so that will basically scroll the texture really fast. And the way you control the speed is by multiplying the time value and yeah, slowing it down or speeding it up that way. Yeah, so that's what the time does. It's really helpful for making animated stuff. Yeah, and there's also the step node, which acts as kind of a threshold. So if you have like a noise, for example, and you want it to either be 1 or 0, and you don't want any of like the in-between values like 0.5, 0.6. and stuff, you can use this step to threshold the value so that everything under the threshold gets set towards 0, and then everything above that threshold gets set towards 1. Which makes this kind of effect, which is really cool for like cell shading. Yeah, and there are also inputs about the position of things. So like either the screen position of the camera, where the object is, and there's also like a position node that tells you where the object is in terms of, oh, sorry, not the object, but the vertex of the object is. And that's in relation to either the object itself or the world, or you can, there's a drop down where you can select a bunch of different values. And in the same picture, you will also see the split node, which will split kind of like, because when you look at the node's output, where it says like out bracket 3, that's how many values is combined into that output. So basically, if you've done vector math before, you would like, that is a vector 3 output that combines 3 different numbers into one output. And so you're splitting those 3 numbers into these values so that you can manipulate them individually. For example, if you only want the horizontal axis or vertical axis, that's how you would split it. Yeah, and finally, the output nodes are how you would actually output those 2D graphics into and map them towards the 3D objects. So I've grayed out the ones that are less useful, but some cool things you can do with it is connecting stuff to the vertex position and kind of like adjusting each vertex and how they move. That's how I did the fish shader, for example. And there's also inputs for color and alpha. And the difference between the unlit master node and the PBR output is that unlit doesn't react to the lighting around it. Meanwhile, the PBR node at the bottom, you can see that it has shading, it has like a little highlight, and you can tell that it's a 3D like sphere. And so Unity does like a lot of the rendering for you, but if you are making like a stylized game or an anime game, you don't need that kind of shading. So you would be using an unlit node so that you can do like the lighting effects yourself. Yeah, and there's a couple more options for the PBR node, such as smoothness of like emissions, metallic, and stuff like that. Yeah, so now it's time for the demo. So we'll be making this kind of like swirly portal shader, and we'll be using a bunch of what we talked about just now with the nodes. Cool, so we have this here, and I'll take you through the process of making stuff like this. And it doesn't have to be like a 2D thing as well. And you'll notice the back isn't rendered, but there are settings for that. Yeah, you can do something like a ball. You can really apply this to any kind of material. Yeah, so the first step is to make a shader. And down here in the project file, you can go to the context menu and click Create Shader, and then unlit graph. Make sure it's on the graph instead of any of these shaders, because these are the ones that actually require you to write code. Yeah, I'm gonna call it Portal 2 because we already have a Portal 1. Yeah, so the next step to actually get Unity to make it a material is to right-click on the shader that you made and and create a material from that. Yeah, so it should name it Portal 2 automatically. The other way you would do it is just to drag the shader into the material. And so shader and materials are different things because materials are the things that you actually apply to the game object. Yeah, you can also select stuff here. And so let's go ahead and drag the material onto your quad. Sorry, I should have made y'all make a quad first. So to make a quad, you would just click in empty space, 3D object, and here's the quad. Or a cube or a sphere, whatever thing you want to make the swirly shader for. Yeah, it looks like, even looks like, sure. Yeah, so it looks invisible right now. It's because it's only shaded on one side. And that's to save resources, but you can spin it around like so. Yeah, so now that you have that, I'm going to drag the portal shader onto here. Yeah, there we go. I'm going to double click the shader to open it up. And you should see something like this, only the unlit master. Yeah, so the color node, for example, it just changes the color of the surface. So you can set it to like green, my favorite color. And you would click like Save Asset over here. And you can go back to the scene and you'll see that it has changed to green. And it doesn't have any shading or shadows and anything like that. Yeah, so actually let me maximize this so that we get all the screen real estate that we can. Yeah, another thing to do first on this node is to go to settings and click transparent. So there's a setting on each node that lets you set different things about it. This is where you would set two-sided as well. And so remember when one of the faces was invisible? By setting this option, you'll let it render on both sides. So set it to transparent and then set it to two-sided. Yeah, so now that we have that, we can kind of like lower the alpha. And this is just to show you how the transparency works. So save asset and go back to see. Yeah, so now it has transparency and you can see it on both sides. Yeah, so that's the basic setup for the output node. And let's start putting in the fun stuff, which is the noise and all that. So let's actually start with the noise. So let me show you how the noise works. So we're going to type, with this, I was using Voronoi noise. So let's use, it's such an obscure name, but it's like a common thing in 3D graphics, which is why I guess you just have to memorize that name, Voronoi. But also you can find it under procedural, noise, and then Voronoi. And that's the three noise that I was talking about. So Voronoi will give you this, and when you connect this to the output, it will give you this. And when you connect this to the alpha, and remember when I said that black has a value of 0 and white has a value of 1, that will actually, when you port that to the alpha, it will follow those values. So if you click save and look around, you'll see this kind of value, or this kind of effect, where it's transparent only in the places that shows us black over here. Yeah, so a cool thing you can do with Voronoi as well is that you can adjust the cells. Or a second output that it has is the cell output. And when you connect this to this, you'll get some interesting effect, like so. So it can actually output some solid-filled cells, like this, and you can use that to make kind of effects with more sharp edges, which is really cool. And let's do that first because I think it looks better. Yeah, so in order to kind of warp or distort the noise texture here, we're going to add a UV node. Sorry, not that. So we're going to go to UV and then go to Twirl. That's the node. So you can already see that it has like, it looks something like the one that we're showing. So when you connect this output to the input of the UV slot on the Voronoi, it's going to twirl around like that. And so you can adjust the strength, like so, and you can also adjust the offset, which will give it kind of like an animated view. an animated kind of style. Yeah, so I'm going to set that back to 0 and have the time node control it. You can also set the center, which is interesting, but we're going to keep it at the center right now. Yeah, and as for the Voronoi node, you can also set, so the angle offset actually just makes it more, it gives us it gives it more white values than black values, for example. And then the cell density, you can make it like more or less dense, as the name implies. So this is what it looks like. It just kind of shifts the cells around, and this one will give you more or less cell density. Yeah, so we're going to plug that back in, and then we're going to add the time node. So you can, shoot, I totally forgot to explain. Yeah, so the way you add a node, totally slipped my mind. I press space, and it'll pop out this this like node menu. Sorry, totally forgot. Or you can right-click and then click create node, like so. Yeah, but that's the keyboard shortcut for it. So I'm going to type time, and I'm going to link this to the offset, and you'll see that it will animate on its own, like so. And if we look at it right now, we can save asset, and then go back to the scene, and it'll look like this. Yeah, so let's talk about how we can adjust these time values. So over here on the left is the properties panel, where you can add different values that show up in the inspector. So over here in the inspector, you would expand this menu, and right now it's empty, but once you add something here, it will show up, for example, different values that you can set without going into the shader. So designers can be like, hey, I want this to be more slow or faster, and then they can adjust things in the inspector instead of going into like your shader code and tweaking the values there. Yeah, so the way you make time slower is to multiply it by a smaller value. And so we're going to add a multiply node right here and change this to 0.5, for example. And then we're going to connect this back into the twirl. Yeah, so it's a lot slower. You can adjust the speed. You can make it extremely speedy. You can even go negative, but we're going to keep it to like 0.2 or something. And we're actually going to add a vector 1, which is really just a float value, but I don't know why they call it like a vector 1 instead of just a float. But if you make a vector 1, you can call it speed. And you can set the default to 0.2, which looks nice here. And you can drag this out into the shader graph and connect that as a value to multiply. So then whenever you adjust the value here, it's going to change here as well, like a variable. And so when you save this asset, it will show up over here as a speed. And when I go into my scene view, I can directly adjust the speed here without ever touching the shader. So that's really useful for designers, for example. Yeah, and there's a whole bunch of different values you can add. I think gradient is the only one that doesn't work like that. So even if I add a gradient here, you might have to go into the shader to adjust it. But I think any of these will work. Something like color, for example, you can link to here. But yeah, that's the time node. And now, yeah, it's already looking a lot like the shader in the example. Yeah, so one of the last things is to make it so that it's a circle instead of just like a square, like so. And we're going to use the ellipse node for it, ellipse. And it literally just gives you a circle. And so we're going to set the width and height to 1 so that it's a lot bigger. And we're going to do the thing with the mask that I talked about, where you multiply the two together so that you only get the values that are both a value of 1, for example. Yeah, so you get this kind of mask onto here, and then you can set the output to the alpha, like so. Yeah, so there we go. We have the portal shader. And there's a lot more polish you can add to it, like I did to the one in the example. But already this is looking like a portal shader. Yeah, cool. And I can talk a little bit about what I used to make it look the way it did in the original shader, and kind of what I added to it. So I can run that through. So how I did the kind of soft edges, actually, let's start with the gradient, because that's really cool. And so a common effect you would use in combination with these like black and white values would be a gradient. So if you type sample gradient, it will give you this gradient node. And you can set it to something like this. And you can actually map values to different positions on the gradient. So for example, if you give it an input of 0, then it will be mapped to the orange node, or like the orange side. And if you give it a value of 1, it will be mapped to the red side. Yeah, so and this time input is where you would map those values. So for example, I can drag this here, and it will give me a gradient of things that, like a colored gradient that is being mapped to these values. So I can drag that into the color input, and it's no longer green, unfortunately. Yeah, so you'll get this. It's not much of a gradient because we also set like the 0 value parts to the same parts as yellow, so there's actually no yellow, but we'll reverse it just for Beth. Yeah, so you can actually make this a little shorter. So you have something like this that's a lot more obvious. You can also play with the angle offset to make it like more yellow or more red and stuff like that. Yeah, so now you have a really clear gradient that's going to show up like so. Yeah, so that's how I did the gradient. You can also make it so, you can also use some of the gradient values from the Voronoi shader, the Voronoi node, so that it doesn't look, so that it doesn't have like the hard edges. And so, yeah, you'd have to adjust the angle density, for example. You'd have to move this a little bit. But yeah, so this is something like more like the shader that I made before. So you'll look something like this. And so if you're going for like a realistic game instead of a stylized one, you would probably use something like this. And you can also add something like you can also multiply this. You can directly multiply values like this to give it, give it more exposure, or underexpose it, for example. And then you can actually clamp this to, I think when you input this into the gradient, it does that. Yeah, so usually, like right now, some of these values are over 1, but if you put that into the gradient node, it will actually like smoosh everything above 1 into 1 and make it yellow. Yeah, so you can adjust the amount of yellowness in this, like so. and I also, so you see how it moves a little differently from the example shader? The reason for that is because you can actually add UV effects together. So I think in that one I did like add this with a radial shear. And a lot of this is just trial and error and seeing like what shader works best together. And so when you add them together, it will give you like some wonky effects like this. So you can say, I want the strength of like this, and then you won't have like the center. Yeah, and it will just be a different effect, for example. You can also play around with, for example, the size of the noise. And so if I drag it here and then I drag it to the cell density, then I can adjust the size of things. So it will make it look a lot more like watery and magma-like. Yeah, actually I should do this as well. There we go. Yeah. Oh, okay, I see what happened. Yeah, so I actually have to, instead of putting that here, I should have put it here. That will retain the ellipse mask. Yeah, so this is just me tweaking values and kind of like adjusting the shader. You can make it really crazy like this. But yeah, you can have a lot of fun just like playing around with the values and seeing like how they interact together. And there's a whole bunch of different nodes in here that you can explore. But yeah, so that's the demo. Those of you following on video, and everyone else, of course, as well. Feel free to reach out if you have any questions. Thank you for attending this talk. It's been really fun. So here's my Discord and email, and so if you have any questions, feel free to contact me about shaders.